So Arduino is asking us to compare an absolute value function to the parent graph, y equals absolute value of x, and how it's been shifted, okay, or how it's been transformed. Okay, so we want to remember our general form of an absolute value equation, right? Y equals a times x minus h plus k, where our h value is doing our shifting left and right, and our k value is doing our shifting up and down. And the a value is talking about how wide or narrow the graph is and whether it opens up or it opens down. Okay, so compared to our parent graph, we can see in y equals x minus 2 plus 4, we can see an h of negative 2, an h of positive 2, because remember that minus is a part of our function, a k value of positive 4, and an a value of 1. So with that, we can see that it has shifted right 2 units, up 4 units, and that our graph opens up just like the parent graph, which would mean it has a minimum value. Okay. On number 2, y equals negative 1 times the absolute value of x plus 3 plus 5. Remember, the only way to get that positive sign there would be to do an x minus negative 3, meaning our h is negative 3. We can see our k value is positive 5, and then our a value is negative 1. So it's been shifted left 3 units, up 5, and then we can say it opens down with an a value of negative 1, or you could say that it's been reflected over the x-axis, which would mean that it now has a maximum value. So today, again, really important we understand our general form of an absolute value function. Rather than graphing today, we are going to be given a graph and asked to name that absolute value function. So we're going to do that by determining our h and our k values from our vertex, and then identify the a value, which really works as our slope. So really looking for that change in y over change in x, and remembering based on how it's opening up or down, that's going to tell us our sign. So if it's opening up, it's positive, and if it's opening down, it'll be negative. Okay. So in our first example, we want to first identify our vertex. We can see that that's negative 2, 1, which tells us h is negative 2, k is 1. Now we want to find another perfect point. I can see one right here where we're going up 1 to the right 2, which would tell us our slope is 1/2, or in this case, our a value is 1/2, and it's opening up, so it's going to be positive. So we're going to say a is positive 1/2. Okay. From here, we're just going to substitute into our general form of an absolute value equation. So y equals 1/2 times the absolute value of x minus negative 2, so plus 2 plus 1. So there's our equation. Okay. Let's look at another one. Right, I want to notice this time, right, it's opening down. Right, so I know a is negative. And just keep that in mind for the rest of our problem. So finding our vertex, we can see that it's the ordered pair 3, 3. So we know h is 3, k is 3, and now let's find our slope. So another perfect point, I'm going to use this one, right? So I can see we're going down 3 to the right 1, right? And we want our slope to be negative because our a value is negative. So negative 3 over 1, so a is negative 3. Had I looked the other way and thought about this as a perfect point, right, I would still see going down 3, but this time to the left 1, and I just have to make sure, okay, I know it's opening down, it has to be negative, it's negative 3. Okay, so substituting in our equation is y equals negative 3 times the absolute value of x, h is 3, so minus 3 plus 3. Okay, and there's our equation. Okay. If we want to check our work, we can check our work by using the graphing calculator. So I'm going to show you now how to use the graphing calculator to graph an absolute value function. So let's grab our calculators. I'm going to go to the y equals section. I'm going to put in both so we can see how they go. So as always, right, y equals, now we've got 1/2. Again, to get our fractions, we're going to do alpha y equals, I put that in there, 1/2. Now the new thing is we have to get our absolute value bars. To get the absolute value bars, we're going to click math, arrow over to number, and then number 1, ABS, that stands for absolute value. So I'm just going to push enter. Okay? And it brings up our absolute value bars, and then we're just going to type what we had inside, x plus 2, arrow outside of the absolute value bars to put our k value. Okay? Let's put in number 2 so we see that all happening again. So y equals -3. Now we need our absolute value bars. So again, we're going to go math, over to number, and enter at 1 to get our absolute value bars, x minus 3, arrow out of the absolute value bars, plus 3, okay? Then we can zoom 6 to graph, okay? And we can see our two functions, okay? So we can see obviously the scale is a little different, so they don't look totally identical, but we can see well enough to see that we were correct in naming those equations, okay? So in our classwork today, we have a little bit of a mix, naming our absolute value functions and then getting back into describing those transformations. So finding the vertex, talking about if it's opening up or down, if something has a maximum or a minimum, so I'm going to circle it, and then that maximum would be the y value of our vertex point, okay? All right, and then just kind of a little bit more graphing practice as well.